morning, class. Welcome to week 6 of ABO. We are looking at our exam prep parts 7 and 8, the last of the books. Just a little bit of math in this book, and it's really a discussion about dividing Prism or splitting Prism, and then a little bit of like canceling and compounding Prism as a part of this conversation. So I'm on page 7. We're looking at the example in the middle of the page there, and basically they're showing us that we're looking at a right eye with a +1, a left eye with a +1 sphere, and the doctor has prescribed 2 diopters of base up Prism for this particular patient's right eye. Now, in reality, the lab would not make all of this Prism in the one lens. Having, 2 diopters, additional Prism on just the right side does definitely change the weight of that lens and the thickness of it. So for purposes of making the glasses more balanced and more cosmetically appealing, generally the lab will split the Prism up between the 2 eyes. So instead of prescribing or making a pair of glasses with all of that Prism on the right side, instead the lab's going to keep, of course, the distance portion the same. And then we need to keep the direction in the prescribed eye. So because the right eye has base up prescription in the original prescription, we need to keep that base up in the right. This is going to ensure that the patient gets the proper correction. But then we want to split up this 2 diopters, and we want to split it evenly between the 2 eyes. So if we have 2 diopters total, we're going to put one of those diopters of Prism on the right side, and the other is going to go on the left. And in order to create compounding Prism, which is what we're doing here, we need the left eye's base direction to be the compounding version to base up. So base up and then base down are the compounding combination. So we would see this original prescription written like this second one once we received that from the lab, and we would find that the lab had placed 1 diopter of base up Prism in the right eye and 1 diopter of base down Prism in the left eye to help balance these glasses. Let's go ahead and get rid of these guys and just have a quick discussion about canceling and compounding directions. So if we have canceling Prism, that means that the Prism in the one eye would cancel out the Prism in the other. Prism thinning is a perfect example of canceling Prism, and we would see directions base up and base up, base down and base down. If we saw a base in and a base out, or a base out and a base in, all of these situations would be considered canceling. And it's because all of these Prisms are going in the same direction. In and out, same direction. Up and up. We are headed in the same direction. In a compounding situation, we will be going in different directions. So our different directions include like a down and an up and a down, an in and an in, or an out and an out. So we can see from our previous example, we can see this particular combination, that base up and base down that we saw in our previous example, That was our compounding situation. Now we would see in a canceling situation, let's say that we looked inside of the lensometer. So we're looking at our reticles, and in that situation, of course, we've got our reticle rings. And if we saw in the right side that the optical centers of those lenses crossed, like let's say right here at this first ring above, and then we switch to the other side of the lens, and we see again that those reticle lines are crossing at that first ring above, we would say that this is a canceling situation, because here we are, two lenses, right and left, both with the same amount of prism in the same direction. So the one diopter of base up in the right eye has canceled out the one diopter of base up in the left eye. The patient is looking through the same portion of the lens, therefore they do not experience any prism in this situation. However, if we are now using, let's say, the example that we were talking about earlier, where we had our up and our down, if we were to look through our lensometer at our reticle rings in this scenario, our patient's right eye had a diopter of base up. So again, we would see that optical center crossing right at that first ring above the bullseye or above the reticle. And then we would have seen on our left eye that optical center being found right at that first ring, but now we're below the bullseye. So this is our one diopter of base up in the right, our one diopter of base down in the left. And because of that movement, we had to travel through the optical center and then down to that first ring. That created two total diopters of prism. This one created 0 here at the top. This one here at the bottom actually created 2 diopters. So we have a canceling situation such as prism thinning at the top, and then our compounding situation at the bottom. Now there will be occasion that we see a canceling situation. However, it is not a completely canceled prism. For example, if we were to see that there was, let's say in our right eye, and the distance portion of the prescription or the regular part of the prescription really doesn't matter, but if we had, let's say, 3 diopters of base in prism prescribed to the patient's right eye, and for some reason we were seeing that there was 1 diopter of base out prescribed for the left eye, because of our earlier canceling conversation, we know that in and out are a canceling situation because those do go in the same direction. So again, if we're looking at our patient, right, here's our patient's eyes, and in the right lens, we needed 3 diopters of base in. So that means that that optical center is placed in this way, and in the left eye we had 1 diopter of base out. Again, we've moved in and out, and we have created a situation that is partially canceling. So our 1 diopter of base out prism in the left eye does partially cancel out our 3 diopters of in the right, but not completely. So if we take 3 minus 1, we find that there are 2 diopters of Prism left, and those are base in, and that still then is in the right eye, because our 1 diopter of base out did not completely cancel out that movement from the 3 diopters of base in the right. Again, let's go back to our splitting situation. We'll do one more quick example before we complete this discussion. So if we had, let's say, just a simple prescription here, and our patient was prescribed Prism, and that Prism was prescribed to our patient, let's say 4 diopters of base down in the left eye. Again, lots of Prism in that left eye, so it would create a very unbalanced pair of glasses. So instead of making all of that Prism in the left lens, the lab would split that. We would have the same distance prescription for both the right and left eye, of course, and then splitting that other. Remember, the biggest and most important thing here is that the original direction, so the base down in our patient's left eye, is critical here. So we do need base down in the left. We need that compounding direction for the right eye, so we would do base up in the right side, and then we're just going to take that Prism diopters of 4, and we need to split that between our right and left side. So we have, in this particular scenario, 2 diopters of base up in the right, 2 diopters of base down in the left, which is the equivalent of the original prescribed prescription, and would allow the patient to see the same as the original prescription, along with having a much more comfortable pair of glasses. Thanks for joining the video today. Please call if you have any questions. Talk to you soon.